Welcome to This Explainer. Let's jump right in. Today, we're looking at some seriously mind-bending systemic mapping data that suggest our legal, regional, and bureaucratic institutions are operating exactly like a computer's operating system. We're going to map out the foundational rule sets and cybernetic feedback loops that are actually defining our administrative environment.
Here is our quick diagnostic checklist for today. 1. The human operating system. 2. The cybernetic feedback loop. 3. Anatomy of a system crash. 4. Diagnosing the network failures. 5. Tracking the root causes. And 6. 7 steps to reboot.
Section 1. The human operating system.
Okay, before we can diagnose any sort of system failure, we literally have to separate the human from the machine. Picture a dual-axis stack. On the left side, we have the dynamic axis. That represents the operating subject. That's us. It is the very human experience, the active life cycle of change, transformation, and decision-making. It answers, how does the system evolve? But on the right side, we've got the structural axis. This is the operating system itself. It's the rigid mechanism, the architecture, the organization, and the control rules working underneath everything. Much like a CPU running software instructions, this structural layer rigidly dictates exactly how and when any evolution is actually allowed to occur.
This brings us to a brilliant concept the source material calls the systemic axiom. It says, agents move through states via transformations, while functions are organized into structures and governed by controls that produce outcomes. This is so fascinating because it perfectly translates sociology into computing. It means our regional institutions, our courts, our registries, they're functioning purely on algorithmic logic. And we, the active agents, are simply the operating subjects trying to navigate those rigidly governed structures.
Section 2. The cybernetic feedback loop.
So how do these massive institutions actually process our human data? Think of this 4-step systemic cycle progression exactly like a computer processing a command. Step 1, the system is just sitting there in a resting, stable state. Step 2, a functional modification occurs, say you file a piece of paperwork or take an action. Step 3 is structural control. This is where institutional algorithms step in to rigidly audit your action, ensuring it completely complies with their governing boundaries and gatekeeping rules. And finally, step 4, a stabilized outcome. The system takes your incredibly human input, forces it through rigid administrative gatekeeping, and spits out a finalized, newly stabilized state.
But here's the catch. What happens when your human data doesn't perfectly fit into their institutional code? The dataset identifies a severe conflict known as structural rigidity. Basically, when the system's rules and routing schemas are just too outdated or inflexible to handle real human complexity, it simply cannot adapt. It doesn't learn. It just totally rejects or misclassifies the data. Programmers would absolutely call this a system glitch. The source documents identify it as systemic stagnation, a complete structural inability to process anything unconventional.
Section 3. Anatomy of a system crash. To prove this isn't just some abstract theory, let's look at some cold, hard data. We're looking at a real-world network analysis of Seattle's jurisdictional nodes tracked between 2021 and 2026. We've got 57 specific institutional nodes, 80 directional network edge connections, and 7 deeply tracked cases spread across 18 implicated agencies. These numbers are absolutely crucial. They aren't just dry statistics. They represent mathematically tracked institutional realities, mapping out the precise architecture of exactly where the structural network officially fails and crashes.
Now, I want you to notice this highly specific number, 0.0040. In the realm of network analysis, this is the exact betweenness centrality score of the Seattle Police Department within this specific data array. It sounds tiny, right? But in a topological matrix, a number like that is incredibly significant.
And the data reveals exactly why that tiny number matters so much. It maps the department as the central systems bridge, literally the sole meaningful betweenness node in the entire network. It's implicated directly across 6 of the 7 tracked key data paths. Because it holds the highest in-degree centrality, meaning it gets the absolute most inbound references, it acts as a massive structural bottleneck. According to the math, this single hyper-centralized node operates as the active propagator where system-wide coordination just entirely breaks down downstream.
Section 4. Diagnosing the network failures. With our primary bottleneck identified, we can look at the connection edge types to see exactly how the system is breaking. Guys, the data exposes deep-seated algorithmic bugs. Out of 80 total connections, we see 14 systemic flaws and 12 procedural breakdowns. Do you see how heavily weighted it is towards structural failures rather than just isolated user errors? The architecture itself is generating the glitches.
So what do these metrics mean in plain English? We're seeing specific case identifiers routed through highly irregular tracks, things labeled as a municipal filing failure, a medicalization pipeline, or a felony due process collapse. And notice those reach efficiency scores? They are hovering extremely low, around 0.02. This mathematical tracking proves that undocumented procedural routes, like that medicalization pipeline, are completely bypassing the system's standard validation gates. The data is literally flowing outside of authorized programmatic parameters.
The analysis categorizes these as active failure modes. Think of them as severe, system-breaking bugs in the code. We are looking at mathematically verified situations where systems use institutional opacity to deliberately hide data, or use diagnostic looping to trap operating subjects in infinite cycles. We see administrative substitution applied endemically throughout the entire system, where they secretly swap out rules, creating these massive recurring due process vacuums. It's wild.
Section 5. Tracking the root causes.
So, what is the core driver forcing this infinite loop? The data isolates one definitive root cause: the economic incentivization of detention. Translating this out of bureaucratic jargon for a second, the dataset indicates that the system is literally structured to profit economically from detention. And what's truly alarming from a systems architecture standpoint is that the analysis notes a complete lack of any operational mitigation nodes. There is quite literally no line of code written into the system to balance or stop this incentive.
In systems analysis, this is what you'd call a node omission deficit. Because there is an absolute absence of a reform node for this economic driver, the system just loops continuously across its structural layers. The underlying logic dictates that the system must continue executing its function, and with no command to terminate or mitigate, it results in a non-terminating operational iteration state. In software terms, it is a true infinite system crash.
Section 6. 7 steps to reboot.
Well, a crashed system has to be restored, right? The source outlines a preservation protocol to finally patch the network. Phase 1 begins with recognition, systematically identifying these structural anomalies. Step 2 is elevation, strategically backing up and preserving historical, non-standard records. And Step 3 is extraction, which is successfully decoupling the target data elements entirely away from the corrupted host network so they can't be further misclassified. The final boot sequence actually requires running completely independent architecture. Step 4, autonomy, requires us to establish sovereign operational runtime profiles. Step 5 is parallelism, where we execute concurrent documentation away from the failing system. Step 6, integration, means synthesizing clean, historical stratigraphic maps. And finally, Step 7 is emergence. This results in the complete stabilization of structural assets, bringing the whole system safely back into equilibrium.
This brilliant dataset really leaves us contemplating something massive. If our institutional architecture is mathematically mapping exactly like a closed-loop operating system, are we merely operating subjects trapped inside a rigid, automated societal machine? And if so, how do we even begin to rewrite the invisible code running our own lives? I really hope this explainer sparked your curiosity to dig deeper into the invisible systems theory structuring our world. Thanks so much for learning with me today.